some series to integral calculus. Some series to integral calculus, mind-blowing war that we have started. So many series we have calculated through integral calculus. Amazing, mind-blowing. I would rather say this is a boon to any mathematics solver. If any person who is solving mathematics, this is a boon. I would try to bring similar kind of thing for in other areas of mathematics. This is called generic mathematics. Can someone solve any problem through only one way? There are n number of series and there are n number of proofs. Okay, where n tends to infinity. Where n tends to infinity means if someone is trying to solve a sum series and he is saying there are n number of sum series, there are n number of solutions, and then n tends to infinity. Only God can learn all this, but there is one way that is generic, and through that way, each and every problem could be solved. Okay, and that we have found is integral calculus, and in that it is successive approximation. So, successive approximation, we can solve any sum series. What is the sum series that we are taking care into? What is the sum series that we are taking care into? And that is 1 to the power 3, 2 to the power 3, 3 to the power 3, 4 to the power 3, plus n to the power 3. This is the, or I have a, I have a series of 1, comma, 8, comma, 27, comma, 64, comma, 125, comma, and so on. Okay, last is n into n, the nth term. What is summation of this series? Divide this problem into n different parts, where the first part is 1, second part is 2 to the power 3, third part is 3 to the power 3. Can we bring into a function? Okay, that we will do. How to represent this series? That is sigma. Sigma means summation sign. Sigma x equal to 1 to n. Summation sign x equal to 1 to n. Function over x. Sigma summation sigma x equal to 1 to n. Sigma x equal to 1 to n. Function over x. Function over x. What is function over x? That is x to the power 3. Function over x is x to the power 3. So, summation x equal to 1 to n, function over x. Function over x is x to the power 3. Means x to the power 3 plus x to the power 3 plus x to the power 3 plus nth term is x to the power 3 again. Okay, what the value is, where x is variable. First x to the power 3 is 1 to the power 3. Next is 2 to the power 3. Third is 3 to the power 3, and so on. What is the summation? So we will go directly. We have already covered one in successive approximation. So quickly, I'll say the fundamental behind the successive approximation. Okay. Okay, for successive approximation, this is x-axis and this is y-axis. Up. Nice one. Okay, this is x-axis and this is y-axis. Successive approximation. Now consider that this is x-axis, this is x equal to 0, 1, 2, 3, 4, 5, 6, 7, 8. When x equal to 1, then I have function over x, that is x to the power 3. That height is 1. When x equal to 2, height is 2 to the power 3. X equal to 3, height is 3 to the power 3. X equal to 6, then height is 6 to the power 3. When x is n, then height is n to the power 3. If I connect all the top point of each vertical bar, then it will go like this. This is called curve, function curve. This is fx, and fx is x to the power 3, where x begins from 1 and ends at n, x to the power 3. But this is not a continuous function. This is a discrete function. Discrete function means in this line only points are there because we connected all the vertical point they are sampled, or I can say this function is discrete function because this is sampled at x equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up to n. This is sampled up to n. Okay, in that manner, there are n sampling we have done of this function fx equal to x to the power 3. For n sampling, first is at x equal to 1, second is x equal to 2, third is at x equal to 3, last is at x equal to n. There are points. This is a discrete function. Each point has a vertical. This is also called point mass function. Now there, now we what we want? We want summation of n numbers. One number is 1, another is 8, another is 27, another is 64, another is 125, yeah, 125, like so. Okay, I have to add all these numbers. Now the question is arising, if I say x equal to 1 and x equal to 2, then there is a width in between. X equal to 1 and x equal to 2, there is a width in between. If I take this width and go along up, then it will meet another function called gx. This is a hypothetical function called gx. This is a hypothetical function called gx. And in gx, it will go from x equal to 1 to x equal to 2. It will go it will go as an area. Area will go and hit gx. Area would go and hit gx. This will become gx dx from x equal to 1 to x equal to 2. Hope makes sense. Consider there is the area strip between x equal to 1 and x equal to 2. This area strip would go like this and it will hit another continuous function. Another continuous, this function would hit another continuous function. Gx, what is gx? I don't know. There is a one fx I know, x to the power 3. There is another continuous function. Continuous function means it is a continuous line. It can be sampled at any x equal to 2.9, x equal to 1.43 whatsoever, where fx has to be sampled only at x equal to 1, 2, 3, 4. This gx, if I take a area strip between x equal to 1 and 2, then it will go and hit gx. This is limit 1 to 2 gx dx. That is the area. Okay, we have seen now how many area you are taking. We are taking n number of area, where first area is from x equal to 1 to 2, 2 to 3, 3 to 4, and last one is between n to n plus 1. Now, if I add all, okay, what is the speciality of this area? The area of gx, if this is gx, hope, if this is gx, then area of gx between x equal to 1 and x equal to 2, this area of gx between x equal to 1 and x equal to 2 would be exactly same as fx at x equal to 1. Fx at x equal to 1, this is the vertical. This vertical will be exactly same as gx area between x equal to 1 and 2. How you know it will be same? We will take gx like that only. That you mean that all the area will be same? Yeah. If I take area between x equal to 10 and x equal to 11, limit x equal to 10, 11 gx dx, this area will be exactly same as fx at left side x equal to 10. Which I am trying to say, if I say fx at x equal to x, that is x to the power 3, will be same as x to x plus 1 gx dx, or summation fx x equal to 1 to n will be same as limit x equal to 1 to n plus 1. Here x equal to 1 to n sigma summation fx equal to limit x equal to 1 to n plus 1, because n plus 1 is the last area, dx dx. Okay, now we will see now, can we take area on left hand side? Means if x equal to 1, then I have fx. Fx is x to the power 3. At x equal to 1, fx is 1. Okay, in that manner, we have x equal to 1, then this is the height. Okay, Let's take area on left hand side. Then x equal to 1 and x equal to 0. I have an area, and that area will go and hit another g2x function. Consider there is another function g2x, not gx. G2x. There is another G2x continuous function for which area between x equal to 0 and x equal to 1 will go and hit like this. Then it will become x equal to 0 to 1 G2x dx, and that area will be same as right hand side vertical on fx. So fx at x equal to 1, then that height means I'm trying to say 1 to the power 3 equal to limit 0 to 1 G2x dx. This means that if I take for any x, then x to the power 3 equal to limit x minus 1 to x g2x dx. If with this from any arbitrary, if I take any arbitrary of any arbitrary x, then between x and x minus 1, if I take a vertical, then it will go and hit gx, and that gx dx or g2x dx x minus 1 to x will be exactly same as if this I have taken this area strip, then right hand side x equal to what is fx, means x to the power 3 equal to limit x minus 1 to x gx dx. Okay, if people are watching our all video, then in the last session we had taken x to x plus 1 right hand side area. We are taking now left hand side x minus 1 to x. Why we are taking so many examples here and there? So that first of all it will come to people's mind that indeed it works with every exam. It's not that we give fundamental and one or two examples we solve and then we pushed out in a way that okay, you can solve like this or something. We will solve it. We are not going away. We will solve it. So now x minus 1 to x gx dx equal to x to the power 3. X to the power 3 equal to gx dx. Gx equal to dfx by dx. Fx equal to gx dx. Gx equal to dfx by dx. In that manner, it will be 3x square. We'll try gx with 3x square. 3x square. Integration will be x to the power 3 by 3. 1 x to the power 3. X minus 1 to x. That will be x to the power 3 minus x minus 1 to the power 3. Okay, x to the power 3, x to the power 3 will go away. Next term will be inside bracket x minus 1 to the power 3 inside bracket. Next item will be 3 minus 3x square. X minus 1 to the power 3 will be x to the power 3 minus 3x square plus 3x minus 1. Minus is waiting outside. Then it will become 3x square minus 3x plus 1. 3x square. Left hand side we have x to the power 3. Right hand side we have 3x square. Means whatever we have done, we have to divide by 3 and multiply by x. So we started with x to the power 3. We started with we started with 3x square. Divide by 3, x square multiply by x. So we have to start with x to the power 3 now. X to the power 3 integration will miss gx. Now gx we are trying in x to the power 3. Successive approximation. Step by step we will do in such a manner that gx dx integration limit from x minus 1 to x, the final what it will come, that will be x to the power 3. Okay, in that manner gx we are taking x to the power 3. In that manner it will become x to the power 4 by 4. X to the power 4 will be x to the power 4 minus x minus 1 to the power 4. Limit x minus 1 to x by 4. X to the power 4 minus, and then in bracket x minus 1 to the power 4. 4. We will solve it. That will be x to the power 4. X to the power is very difficult. X to the power 4 minus 4 x to the power 3. Okay, minus 4 x to the power 3 plus 6x square minus 4x plus 1. Okay, x to the power 4, x to the power will go away. Now it will come as 4x to the power 3 minus 6x square plus 4x minus 1 whole by 4. We will settle it down. Okay, then it will come as x to the power 3 minus 3 by 2 x square plus x plus x minus 1 by 4. Okay, x to the power 3 is there. This is what it wanted. But this extra 3, what we are seeing here, they came as extra, and that we have to settle down. First extra is minus 3 by 2 x square. Now there we will take plus 3 by 2 x square to settle it down. So we started gx with x to the power 3. Now we will do x to the power 3 minus 3 by 2 x square to settle this plus 3 minus 3 by 2 x square. What we have got as the net result, x to the power 3 minus 3 by 2 x square plus x minus 1 by 4. This is what we have got. First, x to the power 3 is the wanted one. Next is minus 3 by 2 x square. For that, we will take plus 3 by 2 x square. So now our gx is x to the power 3 plus 3 by 2 x square. If I solve it, then x to the power 4 by 4 plus 3 by 2 into x to the power 3 by 3. X to the power 4 by 4 will become again minus 3 by 2 x square plus x minus 1 by 4. Now here 3 plus 3 by 2 and in bracket x to the power 3, that will become x to the power 3 minus x minus 1 to the power 3 whole by 3. Okay, x minus 1 to the power 3, how much it will be? X cube minus 3x square plus 3x minus 1. Minus is waiting outside. X to the power 3 minus x to the power 3. Okay, plus 3x square plus 3x square. Okay, minus 3x plus 1 by 3. X cube will go. Okay, then it will come as 3 by 3. Again it will go away. It will come as x square, just x square. X square, okay, x square, and then up x square minus x, okay, because it was x to the power 3 minus 3x square plus 3x, plus become minus, now minus become plus, so it become x square minus 3 minus x, and then at the end minus 1 was there, that become plus 1 by 3. Makes sense? x square minus x plus 1 by 3. Outside waiting is 3 by 2. Then it will become 3 by 2x square, and here minus 3 by 2 is waiting. So they cut each other, gone. So next is minus 3x by 2. Okay, minus 3x by 2, minus 3x, 3 minus 3 by 2x, minus 3 by 2. Last we will see minus 3 by 2x. This side we have x, and this side minus 3 by 2x minus 1 by 2x, minus 1 by 2x is coming now. Net result is x to the power 3 minus x by 2, because minus 3 by 2 settled down. X to the power 3 minus x by 2. Okay, let's take the constant. First time it is 1 by 4. First time if I just take constant, then first time it is minus 1 by 4 that we saw. Next is minus 3 by 2, minus 1 by 4, and then minus 3 by 2. Up. Minus 1, minus plus 3 by plus 1 by 2, minus 1 by 4 plus 1 by 2. We will remember it anyway. Now the current assignment is we are getting 1 by minus 1 by 2x, x to the power 3 minus 1 by 2x, and then minus 1 by 4 minus 1 by 4, and then there plus 1 by 2. This is what I remember. Plus, and that side minus minus 1, plus 1 by 2 minus 1 by 4 plus 1 by 2 means 1 by 4. Net coming is x to the power 3 minus x by 2 plus 1 by 4. That's it. X by 3 is wanted one minus x by 2 is coming extra. So we will place x by 2. So gx now is x to the power 3 plus 3 by 2 x square plus x by 2. We will solve it. Okay, x to the power 4 by 4 plus 3 by 2 x to the power 3 by 3 plus x square by 4, or 1 by 2 into x square by 2, x square by 4. This is what will come. First two term is, we have the answer, that is x to the power 3 minus x to the power 3 minus x by 2 plus 1 by 4. Let's take the last one. Last one is 1 by 4 in bracket x square. That is x square minus x minus 1 whole square. That will come as 2x, 2x, and then minus 1. X square minus in bracket x square minus 2x plus 1. X is gone. 2x minus 1. 2x minus 1. 2x minus 1 by 4. That will come as x by 2. X by 2 minus 1 by 4. All gone. It is completely sweeping now. First we had x to the power 3 minus x by 2. X to the power 3 minus x by 2 plus 1 by 4. What we are getting here? Okay, we are getting here 1 by 4 is waiting outside, 2x. That will become x by 2. My x by 2, just x by 2. Here we have x to the power 3 minus x by 2. Here x by 2, they went away. And there we have minus 1 by 4. Minus 1 by 4, because we started with x by 1 by 4 x square. X square minus x minus 1 whole square. That will come as minus 1 by 2, minus 1 by 4. 1 by 4 minus 1 constant also went away. Means our gx, if gx is x to the power 3 plus 3 by 2 x square plus x by 2, then we have the result. Someone can try. X to the power 3 plus 3 by 2 x square plus x by 2, integration of this gx, then it will come as x to the power 4 by 4 plus x 3 by 2 x to the power 3 by 3 plus 1 by 2 into x square by 2. Limit x minus 1 to x. If someone settle it down, it will exactly become x to the power 3. This is what is wanted. So we got the gx. Okay, what is your great concept of gx? Okay, great concept of gx is, if I have a x-axis and this is a function x to the power 3, then for any x to x minus 1, if I take area strip and it go up like this, and then it hits gx function, g to x function like this, from x minus 1 to x, this area, x minus 1 to x, g to x dx, this area will be exactly same as on right hand side what is gx. Right hand side, right hand side what is fx, that is x to the power 3. X to the power 3 height will be same as area strip between x minus 1 to x. It will go up and then it hits gx like this. If that is true, then we find the gx. If I find the gx, then the full summation means summation of all the vertical, sigma x equal to 1 to 1 x to the power 3, summation of all n vertical will be exactly same, as gx dx. From here it is 1 to n, here it will be 1 minus 1 to n. In previous video we talked about 1 to n plus 1. Here it is 0 to n. That is the difference. Left hand side area we have taken 0 to n. So gx dx 0 to n. Gx is x to the power 3 plus 3 by 2 x square plus x by 2. 0 to n, it is simple now. N to the power 4 by 4 plus x to the power 3 by 3, 3 gone, x to the power 3 by 3, x to the power 3 by 2 plus x square by 4, 0 to n, that will come as n to the power 4 plus 2n square plus n by 4. Is it not the same what we calculated in the previous session? Same, n to the power 4 plus 2n to the power 3 plus n square by 4. N to the power n square I can take as common factor. Then it will become n square, and in bracket n square plus 2n plus 1. N square plus 2n plus 1 is n plus 1 whole square. N square into n plus 1 whole square by 4. Same as n into n plus 1 by 2 common whole square. Amazing, mind-blowing. This is the second proof. What is the third one? Third one is, consider this is if we have taken or something I can proceed upon. People can take care later. So this is x-axis. Then we have taken at any x what is fx, then it is x square. At any x, this height will be same as area around it of width 1, means x to x minus 1 by 2 and x to x plus 1 by 2. This will go as a area strip x minus 1 by 2 to x plus 1 by 2 gx dx. This gx will be different. Means fx equal to sigma x minus 1 by 2 to x plus 1 by 2 gx dx. Okay, then it will be very difficult, I believe. We'll try. There is nothing harm in trying. So, how much it will be? Fx x to the power 3 equal to limit x minus 1 by 2 to x plus 1 by 2 gx dx. Okay, we will try gx with the fx equal to gx dx. Gx is equal to dfx by dx. That will be 3x square. 3x square integration will be x to the power 3. X minus 1 by 2 to x plus 1 by 2. Means x plus 1 by 2 to the power 3 minus x minus 1 by 2 to the power 3. Makes sense? Here everything will be plus x to the power 3 plus 3x square into 1 by 2 plus 3x into 1 by 4 plus 1 by 8 minus and there it is x to the power 3 minus 3x square into 1 by 2 plus 3 plus 3 plus 3 x to the by 1 by 4 minus 1 by 2 to the power 3. Makes sense? Now we will subtract. It is not that easy, but we will do. So x to the power 3, x to the power 3 gone up. Next term is here, it is 3x square into 1 by 2. There it is minus 3x square into 1 by 2. Minus and outside minus is waiting. Plus. So 3x square 1 by 2, 3x square 1 by 2. It will become 3x square. 3x square. Leave the last. 3x square. We are getting 3x square and wanted in x to the power 3. Means I have to divide by 3 and multiply by x. Same thing what we saw earlier. Means we started with 3x square and here I have to divide by 3 and multiply by x. It will become x to the power 3. It will become x to the power 3. It becomes x to the power 3, then x to the power 3 gx. We will start integration again. X to the power 4 by 4. Limit in x minus 1 by 2 to x plus 1 by 2. Okay, x to the power 4, x plus 1 by 2 to the power 4 minus x minus 1 by 2 to the power 4 by 4. Kick start. X to the power 1 by 4, that is x to the power 4 plus 4 x to the power 3 into 1 by 2 plus 6x square into 1 by 2 whole square, 1 by 4 plus 4x into 1 by 2 to the power 3 plus 1 by 2 to the power 4 by 4 minus, okay, x minus 1 by 2 to the power 4. We'll try. Minus is outside and then again x to the power 4, x to the power 4 minus 4 x to the power 3 into 1 by 2 plus 6 x square into 1 by 2 whole square minus 4x into 1 by 3 to the power 3 plus 1 by 4 whole square. 1 by 2 to the power 4. If I settle it down, x to the power 4, x to the power went away. Okay, next is 4x to the power 3 into 1 by 2. Here we have minus minus plus again, so it will become 4 plus 4. 4 4x to the power 3 1 by 2. Here also 4x to the power 3 1 by 2. It will become 4x to the power 3. 4x to the power 3. All right. Here we have 6 into x square into 1 by 2 whole square. Here we have minus, so minus plus gone. So 6 term gone completely. Next is we have 4 to the power 4x into 1 by 2 to the power 3 means 4 by 8. 1 by 2 into x. 1 by 2 into x. Makes sense? This side minus minus plus again 1 by 2 into x. 1 by 2 into x, 1 by 2 into x plus will be x, just x. And this side we have 1 by 8 and this side we have minus 1 by 8. That is gone. Only two terms remain here, not to be frightened. 4x to the power 3, 4x to the power 3 minus x whole by 4, x to the power 3 minus x to the power, I'm sorry, plus x to the power 3 plus x by 4. This is what we are getting. Amazingly simple. X to the power 4 plus x by 3. Wanted is x to the, x to the power 3. X to the power 3 plus x by 4. This is what we are getting. Wanted is x to the power 3. We are getting x to the power 3 plus x by 4. X by 4 is extra. So we will subtract and we will start again. X to dx, we have taken x to the power 3. We will take now x to the power 3 minus x by 4. Okay, integration will be x to the power 4 by 4 minus x minus 1 by 8 into x square by 2 into x square. So this one, first one anyway we know the result, and result is x to the power 3 plus x by 4. Sorry, x to the power 3, yeah, x to the power 3 plus x by 4 minus 1 by 8. And then x square I have to settle down. X square will become x plus half whole square minus x minus half whole square. X square gone away. Next is x here and there also x. That will become 2x. 2x and then 1 by 4 and 1 by 4 will go away. 2x. 2x by 2x by 8. 2x by 8. That will come as minus x by 4. This side we have x to the power 3 plus x by 4. This side minus x by 4 gone. Means perfect. I can take dx as x to the power 3 minus x by 4 and it works. Okay, what would be the final limit? If I'm trying to calculate if this is fx, then we are taking fx at x equal to 1 to n. Sigma x equal to 1 to n fx. This is what we are taking. That will become now limit from, if I take any x then minus half plus half. Now if I take limit then minus half 1 minus half 1 by 2 to n plus half, that is the nth. Now we are taking n sub area. Each sub area is around the vertical. If vertical is at x in fx, then sub area is x minus 2 to x plus 2. First vertical is x equal to 1, then sub area will be 1 by 2 to 3 by 2. So for full integration 1 by 2 and last one will be up to n by 2. 1 by 2 to n plus 1 by 2 dx. Dx is x to the power 3 minus x by 4. Pretty simple. 1 by 2 to n plus 1 by 2. X to the power 4 will become, x to the power 3 will become x to the power 4 by 4. X to the power 4 by 4. X to the power 4 with the limit will become n plus 1 by 2 to the power 4 minus 1 by 2 to the power 4. Okay, 1 by 2 to the power 1 by 2 to the power, both will go away. What will remain there? What will remain there? N to the power 4, n to the power 4 plus, there is no negative here, n to the power 4 plus 4n to the power 3 into 1 by 2. It will become 2n to the power 3, n to the power 4 plus 2n to the power 3 plus 6n square into 1 by 4. Bottom 4 is already there, denominator. So 6 into n square into 1 by 4. That will become 3 by 2 n square. 3 by 2 n square plus plus, and then next will be, oh, it is very difficult, 4n into 1 by 8. 4n into 1 by 8. Okay, we will write again n to the power 4 plus 2n to the power 3, that we have seen already. Then plus 3 by 2n square. Okay, 3 by 2n square plus plus 4 by 8, 1 by 2n, 1 by 2n whole by 4, whole by 4. Now I have to settle down minus x by 4, minus 1 by 4 x square by 2, minus 1 by 8, minus 1 by 8 x square. X square will become n plus, x square will become n plus half whole square minus 1 by 2 whole square. 1 by 2 whole square, 1 by 2 whole square gone away. It becomes n square plus n. 2n into 1 by 2n, n square plus n. So it became, and outside minus 1 by 8 is waiting. Minus, up, I'm all right, I think so. So minus n square minus n by 8. Not correct? This is what I think so. Minus n square by 8. We'll try again if we have not mistaken. Minus x. Okay, first term is n to the power 4 plus 2n to the power 3 plus 3 by 2n square plus 1 by 2n. Okay, plus 1 by 2n. That's it. Last term went away. Whole by 4. Whole by 4 minus 1 by 4 into x square by 2. X square if I take, then it is n plus n plus 1 by 2 whole square minus 1 by 2 whole square. And that would become n square, n square plus 2n into 1 by 2, n square plus n only, and then plus 1 by 2 whole square minus 1 by 2, that will go away. N square plus n square plus n by 8. This is what I think so. Okay, if someone really try it, solving it, I don't know it will come or not. Okay, 4 and 8, common denominator is 8. Common denominator is 8 now. Okay, and now try. Then top here it will become 2n, n to the power 4 will be n to the, or we can just settle it down. Okay, here it is n to the power 4, then it will become n to the power 4 by 4 one side. Okay, 2n to the power 3 by 4 one side, because we don't have to mix with this. Then next is 3 by 2, 3 by 2, that will become 3 by 8 now. 3 by 8 n square, and here we are getting minus 1 by 8 n square. Make sense? Okay, then it will become 2 by 8, 1 by 4 n square. 1 by 4 n square. Last term is, I remember, 1 by 2 n, 1 by 2 n by 4, 1 by 8 n. Here minus n by 8 gone. Okay, at the end what we are getting, everyone has denominator 4 now. N to the power 4 plus 2n to the power 3 plus n square by 4. Same thing. Okay, that will more or less, it will come as n into n plus 1 whole square by 2, n into n plus 1 by 2 whole square. Means this is the a kind of summation of x to the power 3, n into 1 plus n by 2 whole square. We have achieved this through all three measures. Means whatever the philosophy what we are dictating, that this is the way summation of a series can be achieved through the Successive approximation in integral calculus, three sides. If I take sub area, if I have x value, if I have if this is x axis and this is x, any x, and this is fx square, fx at x to the power 3. If I take any x and then take right hand side sub area, any x, take left hand side sub area, and I take any x and around it sub area, with all three area sub area, result is same, n into 1 plus n by 2 to the power 2. Amazing, mind blowing. Okay, please don't mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 is the telephone number. This solution is not available in any of the book. Anyone would try.